All right, so now we're going to look at the distributive law for a binomial times a binomial. So binomial times a binomial looks like something like this. 2 terms in brackets times 2 terms in brackets. Before we do this, we're going to have to go back and look at a monomial times a binomial, just to go back to the distributive law and see what that looks like. So for something like 2 times x plus 3, we know that that equals 2x times 2 plus 2 times 3, which is 2x plus 6. Okay, so this goes back to the 201, the distributive law. Okay. Now, if we replace that 2 with something else, some unknown, then we get something like this. A times x plus 3. Okay, so a times x plus 3, well, it's ax and a times 3. So just like this. Okay. So now that we have something like that, let me just make this bigger here. Okay. So a times x plus 3, it's ax plus a times 3. Let's replace the a with a binomial. That binomial just represents a number. Okay, so if a equals x minus 4, then when we multiply that out, it's the same idea. Okay, we take the x minus 4, treat it as a single number, multiply it by the x, and then the x minus 4 times the 3. Just as if you did that here. So the a times the x and the a times the 3, now it's x minus 4 times the x and x minus 4 times the 3. Okay, we won't have to do all these steps once we get to see a pattern, but this is for understanding it now. So when you do this now, you can rearrange this. You can put the x out in front and the 3 out in front. It doesn't matter what order you multiply in. Okay, you can leave it there and multiply it in as well. I'm just going to write it like this so it's what you're used to seeing. So now with the x out in front, you can take the x times the x times the negative 4, 3 times x, and 3 times negative 4. Once you've got that, you've got x squared minus 4x plus 3x minus 12. Okay? Now you can see that negative 4x and 3x are like terms. You can collect them, and you've got a nice trinomial here. Okay, 3 terms. Now, if we change that, instead of x minus 4 and x plus 3, this is a specific example. This is how it works. If we want to see how this looks in general, well, let's do the a plus b times c plus d, which is what we had up here. Okay, so this is a general look at it. So what happens? Well, that's a plus b groups of c and a plus b groups of d. Okay, so you take the a plus b as if it's a single thing, you multiply it by the c and by the d. Okay, so just like we did in the previous one. That and that. Okay. And once you've got that written out, you can take the c and multiply it by a, and c multiplied by b. Same with that. So you get ac plus bc plus ad plus bd. Can't collect like terms in this one because there are no like terms in the way that it's written as a general way of looking at it. Okay, we could also write it like this. So I've written it in blue here, just in a different order. If I write it in a different order, then we can attach an acronym to it. Okay, so basically the way we're looking at this is for every term in this bracket, you're multiplying it by every term in this bracket. What you don't do is multiply it by the term in the same bracket. You're never going to multiply a times b or c times d. It's going to be a with the c, a with the d, b with the c, and b with the d. Okay? So just reorder it. Same things, just reorder it. And you've got this acronym. First, outside, inside, last. And what does that spell? FOIL. Okay, so it's a common term, common phrase used for, or a word used for the distributive law of a binomial times a binomial. Okay, so the first ones, you're going to multiply the first. A times C is the first. Outside, A times D, the outside two terms. Inside, B times C. Okay, B times C is the inside. And then the last is B times D. Okay, so that's how that works. So you don't have to do all of these steps here. You can just jump right to this last line. First, outside, inside, last. But you do need to understand where it comes from. Okay? So as a quick note, take A times that one, that's the first. A times D, which is the outside, then the inside, then the last, and that gets you this. Okay? Another way of thinking of this is multiply all terms in the first set of brackets by all terms in the second set of brackets. So A times C and D, and B times C and D. Okay, so here's some examples. Okay, so let's take a look at this one over here. All right, so x plus 2 times 3x minus 5. Going the quick way, we're going to multiply the first, outside, inside, and the last. See what we get. So the first is x times 3x, x times 3x. Outside is x times negative 5. Inside is 2 times 3x. And the last is 2 times negative 5. Okay, so that's using FOIL. So x times 3x is 3x squared. X times negative 5 is negative 5x. 6x minus 10. Now we have like terms. Okay, you can put those together. And you get 3x squared plus x minus 10. Okay. Next example. 2x squared minus 3, x squared minus 2x. Okay. Don't forget to use your power rules when you're combining these. Okay. So 2x squared, so the first times x squared is going to give you 2x to the fourth. Okay. And then, so that's the first. Then the outside is 2x squared times 2x, which is going to give you, sorry, that should have been scratched out there. That's minus 4x cubed. The x squared times x is x cubed. 2 times 2 is 4, minus 4x cubed. Okay? And then the inside is negative 3 times x squared, negative 3x squared. And last is negative 3 times 2x, which gives you positive 6x. Okay? And there are no like terms to collect here. Let's look at this one over here. So you get variables everywhere now. You've got 2xy, okay, so that's a y in there, and plus y, x minus 3xy. So you have to keep this organized. So the first is 2xy times x, and that's going to give you 2x squared y. X times x is x squared, then you have the y and the 2 left. The outside, 2xy times negative 3xy, so minus 2 times 3 is 6, x times x is x squared, y times y is y squared. Okay, and then the inside is here, and the last is there. Okay, so I'm going to show you the next one, and you can pause it and try it. Okay, give it a try, and this is what it would work out to. So there are like terms in that one. Okay, and that's it for that one.